Hi guys, and welcome back to the second part of the introduction to Houdini Flip Fluid. This will be a continuation of the first part. If you don't watch the first part, I will highly recommend to watch it before you watch the second one. Let's watch at the couple parameters and their function. We'll look first from the solver side on substeps and velocity smoothing. If you look carefully here, on the left side you have substeps set to 2, and on the right side substeps set to 1. What substeps are? Substeps are how many times per frame Houdini calculates simulation and check for collision. The more substeps you have, the more accurate will be your simulation. The downside of this increasing is also increasing a simulation time. Let's look at the example. And you see on the left side you have more accurate behavior. We're only changing the substeps. The other attributes are the same for left and right. The second parameter is velocity smoothing. On the left side we have it set to 1. On the right side we set it to 1. Let's see the behavior. And you see on the left side or on the right side you get more splashes. On the left side you don't. Another very important parameter is the friction. Friction of the fluid. You see on the left we have set it to 0. On the right we set it to 1. Let's look at the behavior, and you see the result here. You have to take in consideration that the friction works with conjunction with the friction of your collider object. By default, Houdini set the flip friction to 0. That means if your collision friction set to 1 is like a multiplier with 0, you will not get any friction at all. It's just like some multiplication of these two components. Last not least is a particle separation. On the left side we have more resolution, on the right side less resolution, and you will see we'll get more details with a high res sim. Let's see where we can find these parameters. I already wrote it down. Friction and particle separation you can find under the flip object, and the velocity smoothing and substeps under the solver. The velocity smoothing belongs to the volume, and the substeps is the overall substeps of your solver. I show you the two ways you can just change the substeps. One way is the overall one that I set it here, and another way is only inside your flip solver. Okay, let's see where we can find them. First, friction and particle separation. If you go to your flip object, you will find the friction under the physical tab here. By default, if you create your flip object and the Houdini set it to 0, your particle separation, as you already know, is on the particle tab here. And now let's see where we can find velocity smoothing and substeps. Two ways to change the substeps. Okay, if you go inside your flip solver, under the volume motion, you can find your velocity smoothing, and the overall substep you can change on the dot network. You see under the simulation, you can change it here, because it will change if you have the other solvers also here, will change everywhere the substeps. But I will recommend to change it here in this case. I'm sorry. Under your flip solver here, substeps, you can change it here. You can also give the minimum and maximum substeps. In your case, just put it to 2 here, and it will just stay with the 2 substeps for your simulation. Grid scale, as I already told you, the grid scale is a resolution of your volume. On the left side we have grid scale set to 2. On the right side, we have it set to 1.5. And if you look carefully here, you will see this simulation has more details here because our volume resolution is higher than here. I will also recommend not go under the 1.5. Even 1.75 will do the job for you. And now let's see the last parameter we can change is the time scale. What is useful for? It's useful for the slow-mo simulation and also for small size fluid setups. It's also recommended if you change your time scale, if you decrease your time scale, you have to increase your gravity. Otherwise, you have this very strange behavior. If you wanna have something like this, but in a normal case, you have to just increase your gravity. Okay, let's see where we can find these parameters. The grid scale you can change under flip object. The time scale you can change under the flip solver, or you can do it on the dot network level here. And the gravity you can change here. Okay guys, now you're familiar with all these parameters and what they do. I would like to just tell you that this all parameter works in conjunction with each other. You have to do a couple tests and just get the best of your setup. Because I already told you, this depends on your scene. It depends on the size of your scene. Depends also on the time you get for on the budget. Just make a couple tests, do your R&D, make your decision, show it to your client, and just finish this by the deadline. Now let's see how we can create this camera overlay. Put the necessary parameters inside, and then you will be able to flip book it over the night, and the next day you can look at your renderings and compare them and make your decisions. Or if you have a client, to send them to the client and get a feedback. Let's see how to create the setup. First thing we need is a camera. Just control click on the camera icon and you see now we have a new camera. The second thing we need is a font. What I do here, I just parent my font under the camera, and you see now that this font is parented to the camera and it always stays on the front. Okay, let's dive inside and look. What is actually showing here is a text frame and also the edge script expression showing the frame number. In our case is 1006 and show you here 1006. But if you look through your camera, you will not see anything. Let's just hide my info. Because this text is very big first, and also the position is not correct. Let's first scale the text down. If you look here, you can change the scaling here. I just go for 0.001. And now you see the text is very small now. And if you look through your camera, you will still not see it because we have to change the position. I will show you, I just show now the two, and I show you what your camera sees. And now what I do here, I just take this guy and just bring back. You see now we have this text. You can change it here and play with the scaling and also with the distance here. I will not recommend you to put your text far away from the camera. Actually, what's happening then, if it goes inside your geometry, you will not see it anymore. Okay, stay small here. And I would say I just go maybe a little bit smaller here. And now you can just take these two values and place them according to your camera frustum. Now we have this here. Now you can change the color of your text, because if you look here, if you look through your camera, your text is the same color as your background. Let's change it first. I just go inside, just create the color node. And now you can specify the color here. I just do black. And now you see, now we have the black font here. You can also change here the alignment. I also do not the center. I just go for left here, and here you can go top. And now you have to specify position again, because now we just... And now let's put the parameter you wanna change. It's also very simple. Let's put the particle separation here. First you have to go to your setup. You see now we have the particle separation here. What you have to do here, you have to just copy the parameter and paste it inside your font here. Just paste relative references, and now you see you have a value. But you have to put also the text before. This will be a particle separation. And now you see, now you have your particle separation. And if you want to put more attributes, just repeat this process and you will get more of them here on your overlay. In the first part, you already know how to source your fluid. And now let's look at the initial state, how to create initial state and change the initial state with some custom noises. If you look here, we have only our fluid emission with a volume source. And here you get the initial state. Let's see how we can create it. Okay, in the first part, you already know how to create the collision geometry. I just fly through and show you how to create the geometry and then VDB for your initial state, and then how we can put this initial state inside a dot network. We have our collision geometry here, representing by VDBs. What I did here, I create a tube. Then I transform it to the place. I make VDB out of it, and then I use here combined VDBs. The first input is my tube VDB, and the second input is my collision VDB here. And I use here SDF difference here, and by the end of the day you'll get something like this. This is now VDB, and I just create a null here and just put the result here and rename it to initial. This is the setup from the first part. If you go now to your flip object and under initial data, just navigate to your initial null and just accept it. Okay, now you have your initial state. And now if you simulate, you will get your emission and also your initial state. Now let's look at the volume preservation of the initial state. Noise time. Now let's see how we create some noise pattern on our fluid. If we look in the nature, there's no fluid without motion. That's why we have to replicate it in our setup. The idea is to create noise on the points and on a sub level, because on a sub level you can just visualize it and look at the pattern and adjust them. And then we'll grab this noise and update the particle velocity inside our dot network with this noise. You see, we just take the noise here and put it inside particle velocity input. Okay, let's see how we create the noise pattern. As a base, I took here my initial state VDBs, and first I have to convert them to the points. What I did here, first I converted to polygons, and then I convert to density here, not to distance field, to the surface. I convert it to density. If you look here, we have normal fog here, and then I use point from volume to create the points with this particle separation and detail scale set to 1. Then I use point warp to creating noises, and inside the point warp I have two noises, one high frequency noise, frequency set to 20, low frequency noise set to 3. Then I use 4-dimensional noise, and for this I have to have 4-dimensional input here. And what I did here, I just took vector to vector 4, and I add to 3-dimensional position the fourth dimension time, and I multiplied the time also for decreasing and increasing the speed of the animation here. And then what I did here, I multiply my high res frequency noise with a low res power. And then I use the vector to float because I need only one. Here I have 3 colors. Wait a second. I have RGB and I need only 1 dimension to get the grayscale. Okay, let's create it from scratch. Let's create point warp. And dive inside. We will use the curl noise. And you see by default it comes with 3D noise. Now we will use vector to vector 4 to add additional dimension. We have now 3 from point, and we add the time. And if you now connect the output to position, it will automatically just make this noise 4 dimension. If you look now at your result, you'll get this. Now I'd like to just slow down this movement. I will use a multiply and multiply the time with the parameter. You can just middle mouse click, promote parameter, double click. Now you get this parameter. I will say set to speed and also speed here. I will set the default value to 0.1. Now you see we have this. Okay, now let's modify our frequency. What I do here, I just copy and paste relative references here because I like to change the frequency on one place here. Now you see we'll get this pattern. And now let's create a grayscale out of the color value. I use here vector to float. And now we have this. I like to have some randomness because now it's everything like the same. First, let's see which values we have here. We have from 50 to 50. Let's first Oh, let's first create another noise here. Set the frequency to 3 and calculate the length of, or power or magnitude of this noise. Now look at the values here. And now they're coming from 0 to almost 7. I will do a fit range here, and I promote these two parameters. I would say, or you can set it to 7 here. And now let's multiply this noise with this result of this fit. I just say multiply. And multiply this guy with this one. And now you'll get something like this. And now you can just promote these fit parameters here. I just go here and say promote parameter. Also promote this one. And now you can just change the behavior here. If you put it to 50, you will get this kind of behavior, maybe 100, something like this, because it's looking better now. Okay, let's bring it to the top level. I just go inside, just copy this all. I'll go to our setup here, go inside here. Let's create the pop bob. This is the same thing like pop bob on a sub level. I connect this one to particle velocity, go inside here, I just grab and delete all the default ones, and I just paste it here. What we have to change here, because now we applying our product to CD, what you have to do is to apply it to force. And what you also can do to be able to get a multiplier, the overall multiplier of this force, you just promote this parameter with middle mouse click on the parameter, double click on it, and we'll say this is our force, and I will say here force, oops, I think I just say force mult, and here we'll just stay for force. If you go outside here, you can change now the speed, and force I do 4.1. And if you look at your simulation now, let's press D here, just do here dark, geometry pixel, and let's see. Now you see you get your moment here. We have to wait a little bit. Okay, now you see you have your custom noise. Okay guys, let's move on to the last step of this tutorial. In this last step I will show you how to visualize important attributes, because these attributes you will use for further refinement of your simulation. For example, one of the important attributes is the vorticity. Vorticity is where your fluid has a curly motion, and another one is droplet. If some part of your fluid separates from a main fluid, it creates attribute droplet, and then you can use these attributes for creating white water, or for creating foam, or some different shading of these parts of the fluid. Okay, let's see how the Houdini does it, and then we will replicate it with our custom setup. If you go outside your top network, you will get no visualization. If we are inside, you will get this color. Let's see where this color comes from. If you look at your flip object, Under your guides, particles, the visualization tab set to speed. But if you look carefully on your geometry spreadsheet, under flip object, geometry, you will not find the speed attribute. What the Houdini actually doing is giving you some little extra. It is calculating the length of the velocity vector and giving you as a speed parameter. Let's create it with our custom setup to understand how it works. You have your data in the DOP network. Let's first grab this data and bring it to the sub network. For this, I will use DOP import field. As you already know, I just copy and paste these guys, or this nodes was created with Houdini tools here, and I just copy and paste them here. But we will create it from scratch. That's why first thing I need is the DOP import field. Just create one. And by default, you'll get nothing because you have to specify your DOP network. Just drag it here. Specify your default object, because we know our default object is flip object here, because all the fluids is inside this flip object. Let's specify it here. Just go and just take your flip object. But now we don't have any type of data. You have to specify the data type. We can use it from presets. We just say, okay, just give us the flip fluid. And you see now we have our data on a sub level, but we have no visualization. If you look here, you will have this all attributes, but there is no visualization. Let's visualize it. For this, I will use the color sub, and I set this color first to run from attribute, and I choose first the velocity. And you see now it's giving you some colors here. You can change your ramp type to white water to replicate it, what Houdini does inside the DOP network. And now let's create this little extra that Houdini does for you. I just do a wrangle, and I calculate f at speed. You can create your own attribute, and I will say I like to calculate the length of the velocity vector. Okay. Now you see we get this speed attribute, and now let's visualize it here. Just go here and say, okay, I like to visualize the speed. And you see we have something similar. The color are a little bit different because of the range. You have to just, you see now we get the similar result. Okay, let's see how we can visualize one of the important attributes, vorticity. By default, if you create your flip setup in Flip Solver, the vorticity is not activated. First, you have to activate it, and then just resimulate your sim to get this attribute. I already done it, but I show you how I did it. If you go inside your Flip Solver, under your particle motion, you have this vorticity attribute. You have to activate it. I already did it, and I resimulated, and now I have this vorticity attribute here. And now you can visualize it here. If you go here and you will say vorticity, now it's also very wide here. You have to change your range. I think it has to go to 100 or something, or 150, 200. Okay, and now you have your vorticity attribute. Okay, last not least, let's just visualize the droplet attribute. For this, I will just deactivate my initial setup here, or initial data. Just take it away, and I activate the fluid emission here. I just simulate it and come back in a minute. Okay, now we have these splashes here. Let's activate our droplet attribute and then visualize the droplet attribute. If you go inside the flip solver, under particle motion, just activate the droplet, and I set it maybe to 0.75, and you have to resimulate it because now you see it's turning to orange color. You have to resimulate it. Okay, something like this. And now let's visualize this attribute too. You see here, you have your attribute here. You see you have your droplet. And let's visualize the droplet here. I just use the color here. And we just say droplet. And the droplet is the float attribute. It has 1 or 0. If you look here, if we just isolate droplet, you see this attribute is 1 or 0. If it's 1, is separated. If it's 0, is inside or is part of your main flip. And as you already see, you can separate now the areas for white water. And also this is very, very important attribute when you will next take this fluid and make a mesh out of it for rendering, because this little thing will give you a flickering. That's why you have to just delete them. For example, you can say here you wanna blast you see I like to blast the add droplet equal 1, and you have to go to the points, and now you see we blast this all droplets. Okay guys, now you are familiar how to visualize the attributes and also how to use this visualization to just improve your simulation or refine your simulation. Okay guys, that's it for this tutorial. I have a little extra for you. If you have a time and would like to improve your knowledge and put everything you learn in practice, I will provide you with this geometry. Try to create something like this. This geometry will include emitter and also this collider geometry. Just emit the fluid from the emitter, create the custom velocities, and make a proper collision. Okay, if you like this tutorial, just subscribe my channel, stay with me, and I will see you in the next one. Bye.